All right, guys, so before we get started, are there any questions over the homework so far? Any questions over the homework assignments? I believe this is where we stopped yesterday. So, we're continuing on with systems of linear equations. So with these three equations, we want to pick a variable to eliminate out of the other two, and an equation to eliminate it with. Now, 1, 5. Now, as we look at this here, x, y, and z are really all good choices. Because if we look at x, and we pick either the top one or the middle one, they're already the same number 1 and 1. And to get it to be 5x, we just need to multiply the equation by 5. They're the same, we can eliminate it out. If we look at y, well, top two are already 1y. We're not so much focused on the sign, we're just focused on the number. And if we want it to be the same as the other, we just multiply it by 5. What about our z's? They're all the same. They're all just 1, yes? So that's also a good choice. Which do we want to eliminate first? Z. There's nothing we have to do to make them be the same, so we'll go on and do z first. Now, which one is going to be our eliminator equation? Yeah. At this point, it doesn't matter. We just need to specify which one we're going to use to eliminate z from the other two. Now, we can go on and list our non-eliminator equations out. Which one?
Are you serious?
Oh, you wrote the wrong stuff.
Yeah.
Wait, what is all this?
The one, yep.
Oh, like, why are we marking that? Yeah, seriously, bro.
You're welcome. So, now, it doesn't matter which one we do first. We just need to pick one of the two that's not the eliminator to eliminate z out from. So if we look at this one here, we have z and negative z. So we're either going to add them together or subtract them. Which do we think it is? So z minus negative z, 1 minus negative 1. Because if we subtract our negative and negative, make a positive, so we have 1 plus 1 is 2. So we wouldn't subtract, we would add, because 1 plus negative 1?
Equals 0.
1 minus 1 is 0. So that tells us we need to add all the way across. X plus x is 2x. Negative y plus negative y. Negative 2y, negative 1 minus 1, negative 2y. Z plus negative z, 1 plus negative 1, 0. Negative 3 plus negative 3, negative 6. And again, on the other side, we're wanting to eliminate z, since the z's already have the same number in front of both of them, 1. Not caring so much about the sign, more about the fact that the number is 1. We can go on and just line them up. Here, if the signs are the same, we subtract. If the signs are opposite, we add. Positive and negative, signs are opposite, so we're going to need to add. 1 plus negative 1 is indeed 0. So we would be adding. 5x plus x is 6x. Negative 5y plus negative y. Negative 6y. Z plus negative z. Negative 15 plus negative 3. Negative 18. Questions on how we went from 3 equations with 3 variables to 2 equations with 2 variables. We good with this so far? Okay, now we need to figure out which one do we want to eliminate next, x or y. So y. Now, what can we multiply 2y by to get 6y? 3. Since we have a nice number we can multiply it by, it tells me that the 6x minus 6y equals negative 18. We don't need to do anything to it. We can leave it alone. However, our equation with 2x minus 2y equals negative 6, we are going to need to multiply it by something on both sides so that the 6y and our 2y's both have 6. So what do we need to multiply 2y by to get 6y? 3. 3 times 2x is 3 times negative 2y. Negative 6y. Questions?
How did we get positive 6?
Yeah, I just noticed I wrote positive 6 instead of negative 6. Yep.
How come we didn't change anything to the right one? Like the one on the right?
So we're wanting to get the values to be the same, yes? So multiplying the left one by 3 gets that y to 6y. Now the only time we would need to multiply both equations if I cannot get one to match up by itself. Mm-hmm. Add or subtract? Because 6y minus negative 6y, negative 6 minus negative 6, whole bunch of negatives. Negative 6 minus negative 6 is 0. That is what we wanted. We wanted that to become 0. 6x minus 6x. Well, we ended yesterday with this here, didn't we? All the variables canceled out. We got no solution, yes? Before we say no solution, let's see what the other side is. Negative 18 minus negative 18. Negative 18 minus negative 18 is 0 also. Is 0 equals 0 a true statement? Yeah, 0 always equals 0, yes? So what that tells us is that we have infinitely many solutions. Infinitely many solutions. Now, it's not all real solutions, it's infinitely many. Because all real solution says any number set would work. Not all numbers will work. But the number of solutions that we do have, there's an infinite number of them, but just not all of them. Now, we're not going to worry about it too much here because really what it is, this would be the solution set that actually described our infinitely many set. We'd pick a value for y, plug it in, and that would give us a point that works. So we could say y is 3, because 3 minus 3 is 0. Y is just 3, 0. So we just plug in a value for y. So 0, 3, 0 would be a solution. I just picked a value for y. Any value of y works. I could say 7. 7 minus 3 is 4. Y is just 7. 470 works. Any value we can pick for y, we plug it in, simplify the expressions, that's a point that is a solution. That's why we say infinitely many, because we can have infinitely many values for y. But for any of these here, especially if we get infinitely many, we're just saying infinitely many. I'm not having you actually get that set up. We will do that in pre-cal. I will show you how to do that in pre-cal because depending on the setup and the equation will depend on how we do this. Questions on this here? We ready for the next one? X, we have these three equations. So the first thing we want to do is rewrite this or figure out which variable we want to eliminate and the equation to eliminate it with. So we can go from 3 equations with 3 variables to 2 equations with 2. X, Y, or Z, which one do we want to eliminate first? I think Y is a nice choice, yes? Because the number in front of it's all 2. Which equation do we want to eliminate the Y's with? Top, middle, bottom. Top. Doesn't matter. Where are you going?
Let's do the first one. Let's do the first one, guys.
All right, the top. Because it really doesn't matter which one. We just got to pick one to do it with.
Go with top.
We're going with top. 3x plus 2y minus z equals 7. Negative x plus 2y plus 4z equals negative 9. Make that a little more apparent. Since y's are already the same, I don't need to multiply it by anything. I don't need to scale it so that the y's or x's or any of the values match up. Looking on the left, to eliminate z, would we need to add or subtract? So the one on the left, do we need to add or subtract?
Add, because this sign on the same.
The signs are not the same. They are opposite, so we're going to need to add. Because negative z plus z, negative 1 plus 1 would indeed be 0. That's what we want to have happen. So let's look at the rest of it. 3x plus x is?
How about 4x?
4x. Okay. Whatever. 2y plus negative 2y.
0.
7 plus negative 11. Negative 4. So this is interesting because when we did the elimination here, we actually eliminated x or y and z, yes? Now normally our next step is that we go to the other one and eliminate it, yes? How many variables do we have left in that equation?
1.
So why not? Let's just stay right here and solve for x by? Because there's nothing that says we can't just solve from this point here. Because if I get one equation with one variable after doing any elimination steps, I might as well solve for it. That way, if, especially, we solve the next one and we get an equation with x and z, I know what x is now. Even though I don't have a second equation, we can use that value of x to now solve for z. And then plug them back in and solve for y. Does that make sense? Now, if we look at the other equation, because we're wanting to eliminate, we're going after z. No, we're going after y. 2y and negative 2y, would we add or subtract? 2 plus negative 2 is indeed 0. So those would indeed cancel, yes? Negative x plus x. 4z plus z. Negative 9 plus negative 11. So if we'd actually gotten an expression with x and z, we plug x in, solve for z, and then plug all three back into the original one and solve for y. Here, we don't even have to plug z or x back in. We just solve for z. It's all by itself. Last but not least, we have to solve for y. I picked the bottom equation. It really doesn't matter which one we pick. We just got to plug it in one of them. Negative 1 is 1. Plus 2y. 4 times negative 4 is negative 16. One minus 16. Negative 15. Because before we start moving anything to either side, we might as well just combine like terms. Positive 1 and negative 16 is going to make it negative 15. What would we do next? We'd add 15 to both sides, yes. Because negative 15 plus 15 is 0. Negative 9 plus 15. 6. Divide both sides by. Tells us y is equal to 3. So our ordered triplet for this point would be what? Positive 3. Negative 4. Negative 1, 3, negative 4. X, Y, Z. We always order it alphabetically. Questions on this here? Yep, that would give us that. Yeah, 2x and negative 4x. So funny enough, if we'd actually done the bottom one, the other equation would have gotten us xy, or we'd actually had two variables. One of them would have eliminated out, kind of given us x, but the other, instead of having z, we'd actually had 2. So depending on the setup and how we do it, changes the numbers or the look of how we get. We can get different equations. Numbers are still the same, but the equations and the steps change depending on which one we solve for, in what order. Does that make sense? Questions on this here? Questions on anything we've done so far? I think we have 2 left, yes? I will let you pick which one we do, because I think at this point we're kind of getting the hang of it. Kind of, even though, mainly because you weren't here yesterday, so it's a little here and there. After this, I will do more with you. 2 or 3, which one do y'all want to see?
I think you're wrong.
X, Y, Z, what do we want to solve for first? So, or which one do we want to eliminate first? Z's? Either one.
Yeah, go Y.
But why not make it harder? And test our brains.
There we go.
We're going to get there anyways, Gavin.
Yes.
So let's go Z. Top or middle? So we're going to eliminate Z first. We'll do the top one. So we're going to pick the other two. X minus y plus z is equal to 8. And then we have 2x plus y plus 2z equals 16. Now the one on the left, the z's are already the same. They both have one z, yes? So there's nothing I need to do to get the z's to be the same. So we can just go on and match them up, add or subtract them to eliminate z. Would we add or subtract? Because z minus z, 1 minus 1 would indeed be 0 like we want. So we're going to subtract all the way through. Because z minus z is 0. X minus x, 0. Negative y minus y. Z minus z is indeed 0. 8 minus 8. It feels like, well, we got it equal to 0. 0 is still a number, yes? We can still solve. Negative 2y equals 0. We were going to divide both sides by. Negative 2, telling us y is equal to 0. Now for this one on the right, the z's are not the same. The z that we have is 2z. We need to multiply our 1z by something to get it to be 2z. So we're going to multiply it by 2. 2x plus 2y plus 2z, almost wrote x again, is equal to 16. This is going to do something interesting. Add or subtract? Because 2z minus 2z is indeed, let's go through the rest of them. 2x minus 2x, 0. Y minus 2y would be negative y. 16 minus 16 is so it told us exactly what we knew already, yes? Okay. This is one of the interesting cases because it just told us y equals 0. What this is hinting at, and there's a good chance this is going to be infinitely many solutions. That's kind of what the hint is. But to make sure of it, we can go back up here, pick 2 of these equations and plug y in and see what happens. Because if I pick the top 2, or pick all 3, and plug in 0 for y, we'd have x plus 0, which is just pretty much gone. So we'd have x plus z is equal to 8, yes? Second one, we have x plus z is equal to 8. And the last one, we have 2x plus 2z equals 16. What do you notice about those 3? Because the first 2 are the exact same equation, yes? And the third one is just double multiplied by 2. So really what we're saying is comparing x and z, because they're parallel, x plus z equals 8. So I can say x is equal to negative z plus 8, because I subtract z from both sides. It's a line, it's parallel, they're all congruent. This is actually how we get that triplet. Because that line, every point on that line is going to make all three statements true, yes? For a given value x, so x we said here is what? Z, negative z plus 8? And it's based off the value of? But this here is infinitely many. It is infinitely many solutions. We just didn't get 0 equals 0. We got that y is 0. Y is a given value. It's just 0. The other two are related in this fashion. Questions on here? It's kind of weird it works out this way. Because what ended up happening is we solved for one of the values that's parallel that we have multiple values for, and got left with the one that had a single value, just 0. Okay. I'm going to do this again. You don't have to rewrite this. You can just watch. Doesn't matter which one we pick as the eliminator. I'm just going to pick these two. I'm going to eliminate y this time. Yep. Here we would add, yes? X plus 2x is, or x plus x is 2x. Y plus negative y is, z plus z is, 8 plus 8 is. Two y x, that should be an x. Try this again. 2x plus x is 3x. Y plus negative y is 0. 2z plus z is 8 plus 16 is 24. So we still get two equations this time, yes? However, I can't multiply x by a number and get it to be 3x. Can't multiply 3x by a number and get 2x. But what I can do is I can multiply this whole equation by 3 and this whole equation by 2. 3 times 2x is 6x. Here, if I do 2 times 3x, I get 3 times 2z is going to be plus 16 times 3 is 48. 2 times 3z is plus 24 times 2 is 30. Pretty much, we got them to be the same. Infinitely many. So essentially, I removed the one that actually had a value, which gave us our 0 equals 0. It's infinitely many solutions. It works. Does that make sense? So the kind of the big hint with this here, especially if you get a single number, there's a good chance it's hinting infinitely many. Questions on this here? All right, your homework is 3 through 40.
Whoa. Gotta say.
3 through 5, 11, 13. 5 problems. One problem, one of those problems is infinitely many. One of them is no solution.